Hi everyone, my name is Philippe Dourassov, also known as Philvar online. So what I do is that I mainly play CTF. You can see the teams on the upper right, which is the main ones. It's Mountain for the ECSE Switzerland team, Polyglots, which is the EPFL team, and Organizers, which you might know to win some CTF sometimes. When they don't play, there are also a few other teams that I play with, and yeah, that's basically it. So before going into the talk, we quickly need to know a few terms. I assume most of you know what a CTF is, but quickly, it's just a hacking competition where you often play in team and you have a set of challenges that are provided by the organizers of the challenge. You have to hack them, and once you did, you have a flag, which is a string hidden in the depth of the challenge, and you have to. It's kind of a proof that you hacked the challenge, right? And you get the score when you submit it on the platform. The other term to know is cheese. So it's popular in various contexts, in gaming or CTF. Originally, it was used to describe cheap tactics, unusual cheap tactics to win games early. In CTFs, it's quite similar. Basically, it's cheap tactics and unusual tactics that allow you to just solve the challenge without even understanding the core concept, because, well, you can just solve it easier like that, right? And the presentation will be about these techniques, and usually you won't get banned by trying them, but make sure to check the rules before that. And we'll be going from the ones you might already have heard of or wanted to try to the more obscure one that you might not know of. So I'll be presenting 7 techniques during this talk. The first one is about how to find the password of other users when you cannot solve the flag yourself. The second one is about XCS, which is a technique that not many people know about. Don't try to Google that; it will get you wrong results. The third technique is when you have a skill issue in web, you can just make it a crypto challenge and then solve the challenge differently. The fourth one is exploiting a structure that is way too common and that you can see in hack the box machines, for example, or in various CTFs where they share an instance where with too much privileges. The fifth technique is similar to the third one. When you have skill issue in the web, you can just make it a pawn challenge and just use your pawn skills to solve it. The sixth one is about forcing the others to solve it for you. The seventh one is a novel technique that abuses PHP because PHP is broken and you can always find something in it. And it's used to solve a lot of XSS challenges, client-side challenges. So the first one, brute force player passwords. As I said before, I don't want to get you banned or myself banned, so don't try to brute force this on the actual infrastructure. This will likely get you banned, and if you want to have a nice score, you don't want to get banned, right? So instead, what you can try to do is try to brute force the password on web challenges that have authentication features. And it's actually very common in web challenges. Usually you have to become admin or get some type of privileges or set an account. And the thing is that people are lazy, and when people are lazy and want to create an account, they will just put ASDF in the username field, and then they will just copy paste because it's faster and paste it in the password field because that's the quickest way to create an account, right? And they don't really think about the consequences because it's not an important account, right? It will be deleted 2 days after because the CTF will end and they don't really care. And then, they just click on the register button, and you can abuse that. You can just take advantage of that by just waiting for a few teams to solve the challenge, find a password list such as roku.txt, and brute the login form, right? Be careful with this part. If you are too heavy on your brute forcing, you can get your IP banned or DOSD infra. So 30 requests, usually like 10 requests per second should be enough. Use a single connection too. That's some more optimization. And if you want to be a bit stealthy, you can change your user agents to avoid having Python requests in it and being obvious that you're trying to brute force it. Once you have some credentials, because you will find some credentials, make sure to try them and check if the flag is there, because some people didn't solve the challenge, right? And then submit the flag and get the points, just like that. And an example of that was last year's Midnight Sun qualifications. On Multilocks, it was a very interesting challenge, but it was very hard, right? And it was 8 a.m. We spent the whole night with my team trying to find a solution on this challenge. And we couldn't. It was just way too hard for us. So we just changed tactics, right? At 8:47, we tried starting the brute force passwords. After 30 seconds, we actually found some accounts. And turns out one of them had the flag, right? So we went from 10 hours of trying to solve the challenge I don't know how to pronounce, but in a legit way. And instead, we took 2 minutes of brute forcing and we solved the challenge that was, well, too hard for us. So it works quite well. And I actually also noticed that it was Seiyu's account, a very strong web player. So yeah, even the best hackers do this kind of mistakes. So now CTF authors might want to mitigate this by adding password restrictions, right? And this is what happened at Insomniac Teaser 2024. You might have played it. It was a challenge that was called InsoBank, and they did exactly that. If you look at the code here, you can see that if you try to register an account with a weak password, so less than 15 characters long, you will get an error, right? So now we'll be playing a game. A CTF player registers an account with ESDF, but gets an error asking for 15 characters minimum. How does the player react? A. It goes on the password manager and gets a secure password. B. Gets creative and thinks of more than 15 characters long password. C. Control C, Control V, Control V, Control V, Control V. D. And use some bash commands to get a truly random password. Who thinks it's A? Who thinks it's B? Who thinks it's C? Most people think it's C. Who thinks it's D? And yeah, most of you are right. Usually they will tend to do the laziest thing because they don't have time for other stuff, right? So when this happens, what you have to do is very similar to the first strategy. You take the first entries from rocky.txt, you just copy paste it so the password is more than 15 characters, and that this is what this script does. It's not super important, but you can see that it does what I said. It's also use a single connection for that. You just have to use requests.session to have a single connection for multiple tries. And it also spoofs the username and then checks if the flag was solved. So I just ran this on the InsoBank, and after 14 seconds we had the username Chris, which had the password Chris, but he didn't solve the flag. But then we had another account which was Quert with the password Quert, and this one had the flag. So yeah, it just took a minute of brute force to get the flag. So yeah, that was the first technique. The second one is about cross-challenge scripting, XCS. So cookies is an old invention, and they're broken in many ways. One of them, if you look at the specification in the RFC 6265, the cookies are shared across ports when you are on the same domain or IP. And what you can do with that is that you can actually access port from the port 9001 of ctf.insomniac.ch from ctf.insomniac.ch on port 9002. And CTFs usually have more than one challenge where there are XSS or some places where you can input your payload. So most of the time you can just and most of the time in this challenge, if you steal the cookies of the admin, well, you get the flag, right? So what we can do is that instead of trying to find the solution by sending the bots on the page of the challenge it belongs to, you can try to send him to the page of another challenge that you weaponize, such as challenge 2 in this example. And there's a few prerequisites. It doesn't always work. First, the bot has to use the remote IP, remote domain, because sometimes it just uses localhost, and in this case you cannot have it go on another challenge, since locally it's only one challenge that is hosted. There also must be another challenge where you find an XSS to weaponize it, or an RC, because if you have an RC, you can also just change the behavior of the challenge to, just serve some scripts stuff. And you also must be able to send the bots on an arbitrary page, because sometimes you just have CSS injections and it's not enough, right? So if the challenges are hosted on the same IP, you can use this technique normally, right? And this actually happened in GeoGuessr, which is a challenge that I did, so my bad. Oops. It was at XTF calls of last year, and Adragos actually found this unintended where you can send the bot on another challenge. So the situation was that there was this challenge called Digestive on port 9010, and it had an XSS on it, right? So, if you, and on port 9011, there was GeoGuessr, which was another challenge, which was way harder, right? And, you could just choose the challenge by finding the XSS on the easy challenge, then weaponize the thing by having a payload that exfiltrates the cookies. You just send the URL to the bot of the other challenge, and, you use the cookie to get the flag, and from there you can just get enough score to qualify for the finals, because thanks to this cheese, they actually did qualify, so well played. Yeah, so that was the second technique. It's actually very common, the second one. So the third one, is zip crypto and revenge files. So sometimes, yeah, there are people that can find on internet solutions, and, as organizers, you're kind of sad because people didn't really actually try your challenge in the internet way, and they didn't find the cool stuff you wanted them to see. So there are multiple things you can do. Either you don't do anything, either you actually release what is called a revenge challenge. A revenge challenge is basically the same challenge, but it's fixed, right? It's quite easy. And it's generally something that is quite common and accepted. The only thing is that there are some points inflations because unsolved challenges are worth less than revenge ones that were solved. But yeah, other than that, like, it's generally like an okay decision to do. But there is something they have to be careful when people create revenge challenge. Is that when they have patched a challenge and release the new challenge, people can just diff the two versions of the challenge and see what was patched. And once they have noticed, well, they can just exploit this feature because they know which feature is vulnerable. And to avoid that, people will just use the password to secure and encrypt the revenge files. Usually it's the flag of the first challenge, right? But the problem is that many people still use the zip encryption, and zip encryption has been broken for almost 20 years now, and yeah, it's still used a lot. And that the reason for that is that when people just want to encrypt their zip file, they will look on Google, that's the first results. They will just try this command here, and it will work instantly. So they won't look at the little text here that says that it can be easily cracked. No one's look at this text, right? So that's good for us, because we can then use a tool that is called bkcrack. It's an open source tool that exploits this vulnerability, and it allows you to recover these encrypted files. And the thing is that it's not just broken, it's completely broken, because you only need 12 bytes of the plain text to recover the file contents of all of the files in the archive. And because zip encryption doesn't encrypt the files in the archive, you can just like find one of the files that is, for example, picture.png, and picture.png has some headers bytes that says, oh yeah, this is a PNG, this version of the PNG format, and these are known, right? So you can just use these 12 bytes to recover all of the files in the archive. And this situation happened in AZ CTF finals. As on a hard challenge, it had only 9 solves out of 700. And yeah, so the chance had been cheesed, and the author wanted to publish a revenge version, and it was encrypted with a zip password. And if you use the tool to figure out if it's vulnerable, well, you can see that it uses zip crypto encryption, and zip crypto is, well, the broken one, right? So what you can do is just figure out what are the files in there. You can see that there's a tower archive in it, so you just use the 12 bytes of the file format, and you just use the tool, and after 2 minutes, it magically decrypts all of the files, and then you can just diff them and get the flag, right? And this is actually a very useful strategy, right? Even the best teams, currently Chromium is first place on CTF time, even these teams use this technique. So it's not just something that's used when you have skill issues, it's actually something that is necessary at some point. So yeah, that was the third techniques. The fourth one is about exploiting the shared instances where you have RC. And first, I have to explain quickly what is the shared or personal instances. Sometimes there are challenges, for example, a challenge where you have an RC. Usually they should be isolated between each other, right? You don't want someone to deface the website, the front end of the challenge, for example. And for that, some CTFs provide an instancer where you just press on a button and you have your personal instance. And for that, it's quite simple. You just need to have Kubernetes and security nerds such as Nerilect, and magic happens. You can just deploy your challenge very easily. But not every CTF people have such a nerd, and sometimes, they don't have the required infrastructure to have these personal instances. So people try to have workarounds with that. They try to avoid having challenges where RC is required, or they can also try to have low privileges on the users that have RC or read-only file systems, so you avoid defacing stuff. But this is usually not enough. So it works to avoid people breaking stuff, but the thing is that many other attack vectors arise. Such an example is that you can just spam PS to see all of the running processes and just monitor all of the commands that are run by the other teams, right? And doing this, you will very quickly figure out the solutions of the other teams. And this happened in Indiana Jones in Midnight Sun last qualifiers. It was also a very interesting challenge, very cool challenge. It was very hard too. And the thing is that it was on a shared instance, and you could execute any binaries. So to get flagged, you had to execute a binary with an argument, and we didn't have this part yet, but we could execute any binary. And we had an idea for an exploit, but we needed an element, and we couldn't find it, right? So at some point, I just figure out, okay, let's just spam PS, see what are the other teams running. Hopefully, some team managed to try to figure out what happened and what's happening and how to exploit this. And hopefully, running PS will display the commands that they ran. And it actually worked. At some point, some team found the folders that were missing, and we had everything for our exploit. So we tried to run our own exploit. It actually didn't work, so I decided to just run the exploit of the other teams, right? It also works. And just after that, we had the flag. It's just easier, right? So yeah, that was the fourth technique. And the fifth technique is about Chromium end days. So the thing is that, once again, there are a lot of web challenges that are client-side challenges, and usually the bot will use Chromium. And Chromium has a lot of bugs. If you look at this Twitter account that was popped in 2020, in 4 years, basically, it published 4,600 tweets, which are all bug reports from Chromium, and potentially exploitable bug reports, because these are all security-related bugs. So 4,630 bugs. There's a lot of choices on the bug you want to use to exploit Chromium, but these are patched. Right? These are old version, and as soon as something is disclosed, there's already a patch, and the latest version is not affected. So people will just use the latest version of Chromium, right? It should be secure, and no one can use these disclosed bugs against the challenge. But the thing is that it's the latest version at the moment of the build of the image of the challenge, right? So usually CTFs will have to build their image some weeks or a month ago to be ready. When a challenge is ready, they just build the challenge and don't rebuild it in the meantime, because they think they don't need it. And that means that when you download the challenge, you see that Docker file downloads the latest version, but the CTF organizers actually built the image 2 months ago, so they have a challenge of 2 months old, right? So instead of looking at the version locally, you should look at the version that is used on remote, because oftentimes it's different. And you can use the user agent header for that in all requests. And once you have the remote version, you can just look for relevant Chromium bugs, right? So the first one that works quite well is CV 2023-4357, which is an XAC in the browser, so it's quite interesting. It works when the sandbox is not enabled, which is by default on Chromium. But the thing is that in CTFs, it's always disabled, because it's a pain to run the sandbox on Docker, right? So you basically have local file reads. You can read any files on the challenge, and even with these flags, which is basically some mitigations to avoid using endace, well, the exploit works anyway because it doesn't use WASM or the common things that are used. So this works until versions that are from August 2023. And the other exploit that works quite well, this one is an RC, so it actually requires this mitigation flag to be not here. But when they're not here and the sandbox is disabled, you will get an RC, and on a version that is up to the one that that was released in September 2023. So there's an exploit, public exploit by Matt Stacks about it that you can read on his blog, and yeah, it just works. So yeah. Now we'll be taking a look at this challenge, OPRDB. You might have seen it as the Hack the Box Hardest Web Challenge. It's actually very hard. If you look at the difficulty rating here that was rated by the different users, you can see that it's way up, like at the extreme difficulty, right? So this challenge has been retired recently, so I can actually publish a solution without Hack the Box being angry at me. It was retired because 0x22sh actually also found this cheese and reported it to Hack the Box, and since then they just removed it. So I will show you the demo how you could solve it before it was removed. So the challenge is hosted here on port 137. Basically, it's a very hard challenge, so we won't look at what you had to do. But basically, what's important here is that you can so it's running in this container. I can quickly get the IP, and if I put some listeners here on ports, let's say 1231, and I send the bots on 1231. Wait a bit, and we see that the bot does a request, right? And as I said, in the user agent, you can find the version that is used remotely. And you could see that it was using Chromium 112, which is very old, right? So we can use any exploit we want. Now I'll just be running this POC that is public. Basically, is just serving this. It's just serving some SVG with some information where you want your stuff to be exfiltrated. I think it's the right IP. Yeah. And there's also this part, which is the file you want to read. We want to read the flag, so it's in /flag.txt. So we just run this POC. We once again just send the bots, but this time on port 3000. And hopefully we should get an XXC with the flag. Yes, exactly. So that's how you could solve it. It took literally like 2 minutes, which is quite easy, right? If you can solve the hardest challenge of Hack the Box in 2 minutes, well, that's a win, right? So yeah. Now the sixth technique. This one is funny. Just exploit the other users, right? So once again, I don't want to get myself banned or one of you banned. So don't try to get this on working on the main CTF platform. Instead, try this on challenges with XSS stuff, and they're also quite common. Usually, you need to get admin or like I don't know, do some stuff with the admin account, right? Usually, this challenge don't require personal instances, so there will be XSS on shared instance, and the authors just have to make sure that you cannot exploit other users with your XSS. But sometimes they forget, or there's another vulnerability they didn't think about that allows you to exploit other users. This happens at Hack the eBank at DEFCON 2023, and the objective was to get an admin account. And you could send messages to other users, and at this point, I think you might realize where this is going. You could get an XSS in the messages, right? So at this point, your strategy changes from exploiting the website, which was too hard for me, to exploit the players, which looks easy to do, right? So I couldn't steal directly the cookie, but instead I could reset the password of the other users, and also, well, get the email account. So once I have the email and the password, I could log into them, right? So that's what I did. But the problem is that I forgot to have any screenshots, and there was no source file, so I cannot show you screens about this. Instead, I will show you another case where you can use this technique. This one was at OpenECSE 2023, and this CTF was a mess. And nothing was working. There were some good challenges, but as well a lot of challenges that were completely broken. One of them was, well, Hosa. And turns out there was a feature to send messages to the home page, right? And it wasn't sanitized. So the only thing I could do is, of course, redirect all of the users going to run the challenge on a specific YouTube link. You also might guess what this YouTube link is. So yeah, basically, I recrawled all of the CTF players on this particular CTF, and while they were getting recrawled, well, I just went to solve the challenge. So that's got me some time advantage. So yeah, that was the sixth technique. The last one is a bit of a new one. It's about getting the headers cancelled in PHP Apache image. So yeah. This technique is based on another one, which is already well known. It's that when you actually send something before the headers are sent in PHP, well, yeah, what will happen is that instead of PHP just sending the body, like preparing the body and sending the headers, it will just not be able to send the headers at all. It will just get cancelled. So you have to make sure that the headers are the first thing you send. Otherwise, well, everything is broken, right? And this technique was present in many CTFs. One of the oldest one was BBCSP by Terjank, but there was also other places, such as, well, yeah, Integrity Challenge, or I don't know, many places basically. It's a known technique, right? And PHP is broken, but it shouldn't happen on production usually, right? Because people that are careful with that will make sure that logging is disabled, and this is something that is well known, right? But in real life, people just forget about it, think it's not super important, so it still happens in real life. And in CTFs, it's way more common because people don't really care that logging is that warning and errors logging is enabled, right? So people will just use the PHP Apache image because it's the one everyone uses and the easiest one to use, and not disable the logging. And this technique is usable, but only in specific cases, right? Because if you manage to get an error before the header, well, the header won't be sent, and you can exploit stuff without the header that would prevent some exploitation. But in other cases where the header is sent first, well, this technique won't work. Same if you disable error reporting at the very first line, it should also prevent the technique from being used because errors won't be displayed, right? So I wanted to figure out if there's a way to make this technique more powerful and work in this case. And for that, we will need to get an error before even the first line of PHP. And for that, I had to explore the PHP code source. And the objective was to find an error that was created before the first line, that is achievable through a normal HTTP request, because you want the victim to have this request being made, to have the XSS without the headers. And and it must be achievable throughout a request that is a navigation, so you cannot use fetch or any other APIs that would allow you to do funny stuff with headers, right? So PHP is quite a big code base. I couldn't look at all of the warnings or error that would happen, because most of them are not relevant. They would be caused by some random functions that we don't care about. And instead, the better thing to do is to just have an error focus on the thing that is here before interpreting the code, right? And such a thing happened in the super globals, right? So most of these, all of these variables will be populated by some parsing stuff before the PHP page is interpreted. But we cannot control all of them. What we can control is the get parameters in the URL. We can control the post parameters in the body, the files, and the request superglobal, which is basically a combination of those. And if you look at the source codes at these places, you can very quickly see that there are places where PHP will complain because of some errors. These, for example, will complain if the parameters, the get parameters or the post parameters, are too, if there are too many of them, right? And turns out this limit is very low. 1000 parameters is nothing, same for 20 files. So now we take a look at, can we exploit such a thing, right? We have a Docker file that is super simple, right? It's just taking PHP and copying this page. And then we have the header, the CSP that should prevent any XSS from happening, right? And then it echoes your input without sanitizing it, but the header should prevent it, right? So we'll take a look at if we can use this technique on that. So it should be on port 8001. So if you if you pass something like that, well, it will echo it. If you try to put some HTML, it will, well, not sanitize it and display the HTML. Sorry, I will make it a bit bigger. Right, so you can see that it doesn't sanitize it. And if you try to well, have some XSS in there, if you look at the console here, you can see that the CSP prevented the execution of the XSS, right? Now, let's try to hit this limit of 1000 parameters, right? So there's this Python script, many params, that will just echo 1000 times A and the, like this thing that separates the different parameters, right? So we just run that to get a big string like this. And let's try to add this magic string at the end of this URL. And we can see that it actually works. You can get XSS like that. It is super stupid. If you look at the warning, PHP complains, oh yeah, there's too many parameters for me, help me. And then see, because it complained, well, it couldn't send the header that should have prevented the XSS. So yeah, PHP, right? So yeah, I did this challenge. I didn't think there will be so many people that would try this, but these are the people that actually solved this challenge, with the first blood being HashKitten, so props to them. The thing is that that's a lot of people, and I didn't expect that many people would solve it. And I actually said that the solvers get a drink from me, so now I owe 21 drinks to people. I'm financially ruining myself. But yeah, that was the technique. You could use it in CTF 2023. As on a hard challenge, 5 solves out of 981. That's a hard challenge. The context for this challenge is that CTF needed web challenges, and Strelic, well, was one of the main person that could do these. And yeah, Strelic didn't have time to do enough challenge, so he just took an old one of his and added this little header, which basically completely broke the solution of the original challenge, right? You couldn't use the same solution at all. It's completely different, right? But now we know that we have a technique to avoid this header from appearing. So while Strelic was saying, oh yeah, now it's all good, right? It's a different challenge. You cannot use the original solution on it anymore. Well, turns out you can do with this technique. So what you could do is to just find the write-up of the first challenge, the original one. Arc wrote one, so you could just use it. Then you just append these magic strings in the URL to break PHP, basically. You run the exploit, and the header won't be there because of this string. So you just get the flag, right? And this technique is cool and all, but so far we only seen situations where it was just well, preventing a CSP header from appearing or a cache header from appearing, which is not a vulnerability by itself, right? It's just a bypass for some mitigations at most. So let's look at another example where this technique could work. In this case, this is a typical case where there's a PHP server that would have an API that would reflect some inputs, but because of the content-type header, which is set to application JSON, it shouldn't be interpreted as HTML, right? So it should be safe. This code should be safe, right? But yeah, we had this technique. So if you use it correctly, it should look like that. The HTML is not interpreted, but with the magic string, well, PHP complains, and you could get an XSS on this kind of APIs, which is quite cool. So yeah, this technique is fun, but then I just try to figure out if it's common only in CTF or if it's also common in real life. But in real life, turns out there weren't many domains that had well this the display errors feature enabled. there was a bias because I only tried on bug bounty programs on VDP, but out of these, there were only 0.08 that had it enabled. So PHP will not die from this yet. People still know that display errors should be disabled on production. So this is something that you can still use in CTFs because, yeah, as I said, CTFs, well, they always use this image. So yeah, that was the 7th technique. I hope you liked them. And yeah, thanks for listening to these.
Okay, we have time for questions. No questions?
I think there are here.
Sorry.
Yeah, thank you for the speak. Do you know how many followers you are going to lose tonight?
Followers? You said lose or? Why would I lose? Oh, I see. yeah. No, yeah, definitely. They probably won't be happy to hear about this, but I mean, it's fair game, right? It's just a game. It happens.
Hello, great talk. And
Thanks.
I was wondering regarding the first technique that you showed, so like trying to guess the passwords of the users. So have you considered a similar attack, but lower on the CTF Forbidden Tactics iceberg, which is, I think some teams already did that. When you organize the CTF, you actually scrape the usernames and passwords that different teams are using. Because some people don't use like QWERTY or ASDF. Yeah. They actually use some specific usernames and passwords, but they always use the same ones.
So that's a great question. I've already been proposed this technique, but that wouldn't be a nice move. So like, we organize the XTF as polyglots, and we will never do this. Please trust us. No. It's really something like that is that would be an asshole move. So we are not doing this. And instead, on the other hand, what happened is that at some point there was a CTF that I won't share the name. But this one also had accounts, and when you became admin, you could actually list all of the usernames of this challenge. So we did get a list of usernames from another challenge, but we're not doing this on our own CTF.
Thank you.
Any other questions? I'm missing hands. Oh. Well, thank you, Philippe.
There's still.
So, are you saying that if I only hand in my challenge 3 days before the CTF, I can tell the infra guy that it's a security?
Yes. I mean, yes, theoretically, yeah. No, but yeah, usually people will pin the version of the libraries that are used, and if you can make sure that these are up to date when the CTF goes out, well, yeah, that's a security feature. Yeah, I think we can say that, yeah.
Thank you.
I have a question. Have you ever stolen an exploit or a flag from Just Cut the Fish team?
No. I don't think so yet. We'll see tonight.
Now I'm checking twice, extra worried. No, seems no questions. Okay, now for real. Thank you, Philippe.
Thanks.